is trying to figure out what kind of problem it is. All the ones that we did yesterday, and the ones that you guys did for homework, looked like dy dx equals 4x squared, and maybe they told you something like y of 0 is equal to -6. This guy here is what I would call a simple differential equation. A simple differential equation. It's simple because you get the derivative set up equal to a function of the independent variable. And how would we go about solving a problem like this? What did we do yesterday? You're going to find the antiderivative. So a simple differential equation, normally you just integrate both sides. And so for this case, you'd say, oh, so y is the antiderivative of 4x squared. And everyone can tell me the antiderivative of 4x squared?
4 over 3.
Oh my gosh, everyone can tell me?
4 over 3.
4 thirds, x to the third power. Plus c. And that's it? We're done? Final answer?
No.
Right, you're going to go further because what we have here is a general solution, and around here we can go further away.
You have an initial condition.
Right, we've got this guy up here, the initial condition, and you guys know the initial condition. Right, you're just going to go back and plug it in. And -6 equals 4 thirds times 0 cubed plus c. You should get y equals -6. So 4 thirds x cubed minus 6. This guy here we're going to call the particular solution because you know exactly what Charlie is. That would be a really simple differential equation. Is everybody okay? Okay? What makes it simple, and remember you're going to turn it off, not snooze this time, is that you had the derivative equal to some function of the independent variable. This is stuff that we had done before, even if we didn't have a name for it. The class of problems that we're going to work at today are called separable differential equations. And we're going to spend probably the next 2 to 3 days on separable differential equations. We're going to do a lot of application problems. You're going to get really good with the skill of solving a separable differential equation. But first, you need to know what you're looking for. What we're looking for is that you're going to have a function of y times dy equals a function of x times dx. We're actually going to separate the dy and the dx from one another. If you are able to write your differential equation in this form, then we're going to classify it as a separable differential equation. And we have a process, a technique we're going to go through. And for my process folks, you know, you're like the kid who's like, just tell me the 4 steps that I have to use all the time to solve these problems. This is one of those times. Pretty much, David's excited here. I swear, almost all these problems that we're going to work up with are going to be separable differential equations, and we're just going to follow this process. All right, so let's get on this. If I look at this first problem, it says solve the differential equation y dy dx minus 1 over x cubed equals 0, subject to the initial condition y of a half equals -6. At first, there's probably nothing about this differential equation that makes you think, oh, it's separable. I wouldn't just look at a problem like this and assume separable. It'll be separable if we can get the problem written in this form. Everybody okay? So if you can write it as function of y times dy equals function of x times dx, then it's separable. So the first question is this actually separable? Well, let's see. We've got y times dy dx minus 1 over x cubed is equal to 0. And I want to try legal algebra stuff, so that all the y's and the dy's are on one side, all the x's and dx are on the other. Edgar, give me something legal.
Multiply times x to the... Oh, wait.
How about just adding 1
yeah.
over x cubed? So y times dy dx equals 1 over x cubed. Better, still not separable. You know it's separable when all the y's and the dy's are on one side and all the x's and the dx are on the other. Legal stuff. Jonathan, what do you see? Is that legal to multiply both sides by dx?
Yeah.
Sure. So now you've got y times dy equals 1 over x cubed dx. And the question is this separable?
Yes.
Right? Have we separated the variables? All the y's and the dy's on one side, all the x's and the dx's on another. Great. And for the College Board, if this is free response, normally they award the first point there. This first part is just separating the variables. Now here comes the new stuff. What we're going to do is you're going to integrate both sides. So all the work that we're going to do once we've separated the variables is integrate both sides. Integral of y dy. The integral of y with respect to y.
dy over dx.
Not dy over dx. I want to integrate. I need to find some function that when I take its derivative I get y.
1/2 y squared.
Right, trust the instincts here. It's a half y squared plus Charlie.
Oh, I see.
Right, I'm integrating on the left, I'm integrating on the right. The integral on the right, you might think, wait a second, 1 over x cubed.
X over.
Right, we're going to have to do some work here. So maybe the first thing is to make this x to the negative third dx. Power rule says add 1 to the power, divide by the new power. So I've got a half of y squared plus Charlie equals 1 over negative 2x to the negative 2 plus another constant of integration. Is everybody okay with the integrating piece? Okay, I'll take that as yes. Separated the variables. Once you separate the variables, integrate both sides. Now, one thing I want to make really clear here. This Charlie over here, this constant of integration, doesn't have to be the same as this guy over here. And so normally what we do is we'll call it like C sub 1 and C sub 2. These are not the same constants, but this guy's a constant, and this guy over here is going to be a constant. What we've done so far in this piece here is just integrate both sides. And for all the people wondering about the points, normally they'll say if you can integrate one side, here's a point. If you integrate the other side, there's another point. If you remember the constant of integration, there's another point. So 4 points on the free response problem, usually for getting to here. The next move is to solve for y. You want to get basically y by itself. So if I'm going to solve this equation for y, here's where things are going to get a little wild. I want to solve for y, so I want to get rid of the half, I want to get rid of the square, and I want to get rid of C1. Trust the algebra, we're done with the calculus. Ron Beer, what are the algebra skills telling you to do?
Subtract c.
Subtract C1?
C still 1, and then divide by a half.
Okay, hold on a second. So we've got a half of y squared equals a half x to the negative 2 plus C2 minus C1. Is everybody okay with that? Okay, here's the part, little newness. What do we know about C2? C2 is a constant. I don't know anything about this constant, but it's a constant, that's all I know. This guy over here, also a constant. A constant minus a constant?
One big constant.
Is one great big constant. A constant that I don't know minus a constant that I don't know is a constant that I don't know. For those of you that hang out with the Calculus BC kids, you might have seen them do this thing. I like to call this Super Charlie.
Hey.
Super Charlie has the ability to absorb other constants. A constant that I don't know minus a constant that I don't know is our new class mascot, Super Charlie. We're just combining the constants.
Wow.
Okay, I noticed. Oh, really? All right, so a half of y squared equals a half of x to the negative 2 plus some constant Super Charlie. I'm still not done solving for y. I need to get y all by itself. So the clever move now? How about just multiply by 2? Is that legal?
Yes.
As long as it's legal, you're okay. 2 times a half y squared is y squared. 2 times a half x to the negative 2 is going to be x to the negative 2 plus 2 times Charlie.
Should be, isn't that negative?
Negative.
Isn't that, whoa.
Okay.
Because it was negative on this other side.
Ah, thank you.
These points.
There you go, keep giving it away.
Okay.
So y squared is going to be the negative of x to the negative 2 plus 2c. Thank you very much. The goal is to solve for y. You're like one step away from being done. But before we do that, I want to make life a little bit better. What do we know about c? It's a constant. Constant that you don't know yet. So 2 times a constant that you don't know?
Something that
It's still another constant that you don't know. Not magic, just super Charlie. So y squared is going to be negative x to the negative 2 plus c. One last thing to get you to y. Take the square root. But if you're going to do that, you got to do it the right way. If I take the square root of negative x to the negative 2 plus c, I've got to consider the positive and the negative versions. If y squared equals this guy here, I've got to consider the positive and the negative. If I stop right now, well, have we solved for y? All right, mission accomplished. If you stop right now, it's going to be considered a general solution. And a general solution's good unless they gave you an initial condition, in which case you can move from the general solution to the particular solution. It's been a while. Did they give us a particular solution?
Yes.
No, they gave us.
Yeah.
All right, did they give you an initial condition?
Yes.
Yeah, that's this guy over here. What the initial condition allows you to do is plug in the initial condition to figure out what actually is the right value for C. So the initial condition says if x is equal to 1/2, then y is equal to -6. So plug it in. -6 is going to be plus or minus the square root of negative 1/2 to the negative 2 plus Charlie. It's really down here. So I need to figure out C. The only thing standing in your way right now would be all the stuff. I've got to figure out 1/2 to the negative 2 power.
1/4.
Not 1/4.
No.
Not negative 1/4.
That's negative.
1/2 to the negative 2. That negative's in the exponent. So you send the 1/2 to the denominator
1/4.
and square it. 1/2 squared is 1/4. 1/2 to the negative 2 is
1/1/4.
1/1/4, otherwise known as 4. If -6 is equal to plus or minus the square root of -4 plus c, Jose, how you doing? Stay with me. Good stuff happening. I can square both sides. Square it. Square it. We should get that 36 is equal to -4 plus c. Solve it for c. I think we get c is equal to 40. Bad board planning on my part here. Your final answer is going to be y equals plus or minus -x to the negative 2 plus 40. Now, the one rule when it comes to working with differential equations, your answer has to be a function. I need a function that passes through that initial condition. And -x to the negative 2 plus 40 is good. Square root of it is good. But I have to make a choice. Do I want the positive version of this or do I want the negative version? And the way that you make the decision whether I take the positive version or the negative version, look at the initial condition. I need to pick the one that when I plug in 1/2 for x, I'm going to get a -6 out. And so it's going to have to be not the positive, but the negative version. Okay, it looks like a whole lot. No lie, it is a whole lot.
No lie.
Okay? But the key is first recognizing if your differential equation is separable, if it's separable, separate the variables. Once you've pulled that off, integrate on the left, integrate on the right, and then just solve it for y. We stopped doing any calculus about here. And then it was just some algebra, some plug-in, and work it out. Yeah?
So, how many total points?
Usually a problem like this is like 6 points,
So we would give most of our points to the calculus?
which feels good if you're in a calculus class, right? Separate the variables correctly, 1 point. Integrate the left, get a point. Integrate the right, get a point. Remember the constant, get a point. Usually the next place that you pick up a point is if you solve the equation for y, and then the last one comes in if you use the initial condition. This process is what we're going to do again and again and again over the next couple of days. Anthony, you okay back there? No, wait a minute.
Can you repeat why you chose the negative?
The reason that I chose the negative version over here has to do with the initial condition. You need your function to satisfy the fact that if x equals a half, y is going to be negative 6. And the only way I get a negative is if I pick the negative square root. Different initial condition, different choice at the end. Okay, so here's what I want you guys to do. Try this first one. Okay, for those of you that need a process, it's all there on the top of page 2. This first practice problem, before you do anything else, I need to be convinced that this is a separable differential equation. Can you separate the variables? If you know you can do that, then the process takes over from there. See what you can do. Yeah. Can you finish this one off?
Now we just
It's almost.
So this is already like 3
Oh, that's why you just have to go with
Yeah. You get the X's on the side.
Right, you've got to convince me it's separable before you can start bringing it into action.
Yeah. Well, this one was easy. We just added this part.
Can you get all the y's and dy's on one side, all the x's and dx's on the other?
Now we just solve for y.
Perfect. First point.
Oh, this is minus C1. It's going to be big charge times 2.
Are all the friends over here convinced it's separable? Alright, as soon as you get there,
It's going to be 1 squared equals
and then sides, do all the stuff.
yeah. It'll be x squared plus still a big part. Y squared equals plus 60. The square root.
Plus mega charge.
We get a point there. Now we just press it. 1 is negative x squared and then the derivative y
mean the square root?
Don't you know?
What do you mean the square root of 4? What do you mean the 4? Yeah, I don't know what to do from here. What about the C? What about the C?
You got it.
Square.
Try that hard. David. So you separate. Great. Good. Now, let's get rid of the one. Because once you find the antiderivative of y dy, that's 1/2 y squared.
No?
Subtract the c1. Okay,
the
so
two
if you
C's,
take
the bigger
the
C.
y would be plus or minus the square root of all the stuff here. Yes, that's not. What I'm saying it would be very different. It would be the square root of the whole thing.
Why'd you decide to do positive?
So it's gonna have to be a
How come
negative.
negative? Then how did you get 8? That's, you decide the negative when it's a square root. C is plus 8 because 8 is just 8. But you get the negative from the fact that it's a square root. The square root could either be positive or negative. You have to look at this condition, whether it's positive or negative at the time.
You got 40.
So once you plug it in,
Because I feel like
that's how you take it.
I need a negative, but I don't know why.
Right, there is a
Because
process,
of this.
right? You like separate the variables. Y dy on one side, x dx on the other. Great. Integrate both sides. Remember the constant of integration. Solve the equation for y. There's going to be some algebra trickiness that shows up. Use the initial condition. Pick the right version. Done. Okay, so let's work out.
I did this wrong. Yeah. But I
Yes,
did
sir.
it wrong. Because I subtracted from the x side. I subtracted the x. So I got x equals square root instead of y.
Oh yeah, he said.
Yeah. I was
The only thing that's different is the way that I chose to write it.
Oh, so you're doing
Oh
separate.
crap.
Yep. Right, you're going to pick the negative version because you need, when you plug in 1, to get negative 3 is fine. Why?
Literally it's all
It comes down to the initial condition. You need to pick the version of the answer that gives you negative 3. And if the options are y equals plus or minus the square root,
it is. But it's just rewritten.
the negative. I gave you a different initial condition. If the initial condition says y of 1 equals 3, positive, then you pick the positive version. It all boils down to the initial. Well, the reason for the plus or minus is you're taking the square root, right? So when you go into solve,
You knew it was the same problem.
No. Until I realized the initial condition. Because the initial condition is actually the
What's your next number? Or for number 2? Okay, so it didn't look the same as number 1 in the very beginning, but after you separate the variables the right way, they are exactly the same. Good, keep going. Number 3 is going to be more of a challenge.
Oh my god.
Why? I don't know. Write it that way. Okay. So in the world of differential equations, we're only going to be in this world for 2 years. It's all about knowing what kind of differential equation.
Oh my god.
So the differential equation you guys are working on are
cosecant of x
because you
dy.
use algebra to rewrite this differential
I
equation.
don't know. I
All
don't
the
know.
y's
Went back.
No, I didn't.
and all the x's and the x's on this and because it's separable, then we're going to attack this process. We're going to integrate both sides.
I mean, it's kind of
Solve
late.
the equation y.
Do you want some more?
And then you use the integral.
No,
We can't do that till
To figure out what's the right
dx
value.
over dx divided by dx. How do you get dy over
That's it.
on that side?
Why would you
What is it in the?
because you heard, see, I don't.
Is this the same as the other one?
Well, you guys just said,
When you can convince me why you don't have to do number 2, you should move on.
Mr.
You
Lee,
need to keep going. Yes, sir.
how, for number 3, how? Okay, so I did this. How do I get a dy back on this side?
Okay,
Why don't we just subtract the
we just need legal math. Have to stay in the world of the legal maths here.
Can we just multiply times 1 over dy so they would cancel? No.
I wouldn't. Normally, when you're integrating, the dy and the dx is something that you're multiplying by at the end, right? So is the integral of something dx, the integral of something dy. We never have that dy or dx in the denominator. Hold on, Jasmine. So it looks okay. We just rewrite this so far. Okay, I need legal stuff.
No. It's weird.
Okay, so right now I have negative cosecant of x times dy over dx.
It's not there.
Because I was trying to get all of the dx on this, the x's on this side.
Okay, hold on one second. Okay, just quick show of hands. How many of you guys were able to successfully make it through problem number 1? And then realize that problem number 2 is exactly the same as problem number 1. That was not an accident. That was on purpose. All right, number 3, the only part I want to offer any help on is the initial separation.
Because the work is different.
Okay.
It's
Looking
different
for
differential.
legal
Separable.
algebra. If this sucker is really separable, then all the y's and dy's make it onto one side, all the x's and the dx's make it onto the other. Anybody have any good thoughts here?
I have plenty.
Right, David, give me some thoughts.
So I started off by writing it out and subtracting CSC x.
Okay, CSC, how are we really going to say that? Cosecant.
Cosecant.
Is it legal to subtract cosecant of x times dy to the other side?
Yes.
Legal, right? Okay, 1 over y dx equals negative cosecant of x dy. Ramir, what's your advice?
Now, I say you multiply everything on that side by y squared.
By y squared.
Just y.
We can do it.
Okay, is that legal?
Yeah.
Right. You may not all decide to go about this the same way, that's okay, but y times 1 over y dx is just dx. Negative cosecant of x dy times y. If this is separable, big if here, then I need all the x's and the dx's on one side, and all the y's and the dy's on the other. Who sees it? What are you going to do? Legal algebra. Where's the legal algebra here? Noemi, what are you going to do?
Do you add the cosecant of x to the other side?
Add cosecant of x. David, what do you say?
You have to divide it because it's multiplied by 3y.
Eunice, what do you say? Okay, we're going to divide. That negative cosecant of x is getting multiplied with the dy, Noemi, and multiplied by the y, so the legal way to get rid of it, divide. Negative cosecant of x. So dx over negative cosecant of x. If you guys don't mind, I'm going to write it as y dy. Now, before anybody totally freaks out on me, dx divided by negative cosecant of x, no, I don't expect you to know how to integrate it if it shows up that way. But there should be some good trig skills in this room. Dx over negative cosecant of x. Oh.
1 over 5.
You heard him?
I heard you, Marvin. One more time.
1 over 5.
Cosecant is the reciprocal of
sine.
Sine.
So this is really dx divided by negative 1 over sine of x over here. Y dy, dx divided by negative 1 over sine of x, a little keep it, change it, flip it, is going to be negative sine of x dx equals y dy. This one is rough to get the variables separated, but now I bet this is going to be like super fast. Finish off. Negative cosine. So funny, all the people that think that the antiderivative of negative sine of x is cosine of x. It's not. It's not negative cosine of x, Jose. Antiderivative of negative sine of x, cosine. So cosine of x plus c is going to be equal to a half y squared plus c. Right? C1, C2, you want to solve it for y. Juan, what are we going to do? How are we going to solve this for y?
I'm not really sure.
Okay. Hold on, Edgar. I see your hand. We all see your hand. Okay. Juan, are you okay getting to this point? Okay. So let's fast forward. I'll come back to you in a second. I've got cosine of x plus c1 equals a half y squared plus c2. The goal is solve for y. Abraham, how do you feel about solving this one for y? We're going to subtract the c2 over to the other side. We're just doing algebra at this point. Now, once you do that, you're going to have cosine of x plus c1 minus c2 equals a half y squared. No surprise here. C1 minus C2, a constant that I don't know minus a constant that I don't know.
Super Charlie.
That's just your super mega optimum Charlie. Cosine of x plus c is equal to a half y squared. I still haven't solved it for y. So we're going to multiply everything by 2. 2 times cosine of x equal plus c equals y squared. Take a square root. Square root of 2 cosine of x is equal to y, plus or minus in front of it. And then use the initial condition. The initial condition says that if x equals pi over 2, then y is going to be plus 4, plus or minus 2 cosine pi over 2 plus c is equal to 4. Cosine of pi over 2, 0 times 2,
0.
0. So I've got plus or minus the square root of c is equal to 4. Square both sides. I think we get c is equal to 16. Plus or minus 2, square root of 2 cosine of x plus 16 is equal to y. And then stop and make the right choice.
It's positive.
Edgar, why positive?
Because the y value, the one for the initial value is positive. So.
Right, this guy over here is positive, so I'm only going to go with the positive version. There it is. All right, one last one for you guys. Try. Good luck with this one. Let me get myself a better marker. You are right.
Oh.
Wait, you made e to the negative what? E to the 1?
Yeah.
No. Isn't it 1 over e to the
Short
negative?
y equals positive square root or y equals negative square root. The way you make
Are you sure that's how it goes? Because if it
I need the one.
Get rid of the e from the top, or did I just drag the, I mean the e and the y, just to get them together?
I get it.
Should you just put the e and y
I
together,
got
or are we supposed to?
negative 20t to the 4th.
Trusting in
d of t equals negative
I have faith in your.
over e to the negative 1.
I'm not ignoring your question forever. Try it out.
What I did.
Is 22 to the 4
Yeah.
together?
Yeah. Because I added, because as soon as you can add it, so I subtracted this over here, so it's negative, right? And then I multiply by dt, so I can get dt back here. Then after that, I divided by e of negative 1, because you can do that, since they're all multiplied. So I just divided by e of negative 1, and I got dy, negative dy over e to the negative. Then I'm not
When you think you've legally separated it, call me over and I'll give you a clean bill of health. Show me where you separated.
So first I added this part over to this side, and then I multiplied that
Yeah, good. So you separated it.
Bar and dt need to be simple.
That's what we do. Are we not supposed to?
Nice. It's perfect. It's perfect. You separated it. Good. Yeah.
What do you mean like it?
So it's a negative y. It's a negative d.
dy over e. So first, I added this. I subtracted this.
The dy?
Yeah, so then you would just get
Yeah, I
negative
wanna,
20
I
to the
think
4th
people
equals
normally use
negative y
not the
equals
bar.
dy over dt.
The one soap is
I
one.
multiplied times dt,
It's a
Nice.
so I
yeah,
could get
but
dy
like,
by itself.
when you say body
And
wash,
after
it
that,
sounds
I
like
got negative 20.
All right, for the friends that have not separated it yet,
20.
it's for
dy
the
dt is going to be a positive 22 to the 4th e to the negative
body
y.
wash, I think is like.
Multiply everything by
Like a
dt.
liquid.
dy is 20t to the 4th e to the negative y dt. Haven't separated yet. So close. One move away from having all the variables on the right side. And it's this e to the negative y that's the problem. Divide. So dy over e to the negative y is going to be 22 to the 4th dt. If you made it there, first point for separating the variables. How many guys honestly separated? Nice. Martier, next move.
I'm missing a 4. T squared.
Okay, Martier, one more time.
Find the antiderivative.
Okay, you're going to find the antiderivative. Now, I'll tell you, normally when I write these problems, normally when the College Board writes these problems, one side is easier than the other.
Isn't one
The
side
right-hand
have to be
side.
negative?
Hold on. Shouldn't the right-hand side be negative? No, I added 22 to the 4th e to the negative y. So I'm good here.
Oh, no, yeah.
One side is almost always easier than the other.
That's it.
I think the one on the right should be a whole lot easier for you guys to integrate. You can probably integrate this without even thinking about it. The antiderivative of 22 to the 4th,
4t to the power of 5.
4t to the 5th plus Charlie, right? Congratulations, just picked up 2 points. Then the trick is, how are you going to integrate dy over e to the negative y?
dy turns to Charlie.
dy does not turn into Charlie. dy over e to the negative y. Adriana, what do you see?
You can make the y positive because it's in the denominator now.
The exponent is in the denominator and it's negative. If you think about this as like 1 over e to the negative y dy, this guy here is the same as e to the y dy. right? It was a matter of taking advantage of this negative exponent. 1 over e to the negative y is the same as e to the y. Antiderivative of e to the y is e to the y plus some constant. Now, I want to have a quick conversation with you guys and let you in on a little secret here. Every single time that we're integrating, you integrate on the left and you integrate on the right, and you get a constant of integration over here, and you get a constant of integration over here. And the next thing that you do,
Subtract the constant.
you subtract the constants to the same side, and then
Make it into super Charlie.
you make it into Super Charlie. It is 100% okay if you stop writing the constant of integration on one of the two sides. Don't do it to both. You have to have the constant of integration on at least one of the sides. It doesn't matter to me which one. Okay? So if e to the y is equal to 4t to the 5th plus some constant, and my final goal is solve it for y, I need algebra cleverness here. It's algebra, not calculus. Noemi, what's your algebra here?
Oh, you take the natural log of both sides?
Take the natural log of both sides. Is that legal?
Yes.
Absolutely. Natural log of 4t to the 5th plus c. Those guys are inverses. Y is the natural log of 4t to the 5th plus c. Now, for those of you that are like, but wait, what's Charlie? What's the value of Charlie? We're never going to know.
You can go with that.
I didn't give you an initial condition. Without an initial condition, you cannot get past, what do we call this again?
General.
This is your general solution. You're going to stop at the general solution. All right, tonight's homework, and you guys have like the next 3 minutes to get started on this. The last page, don't